Mic check. Okay. Let's go to the header file and add a bool for moving, or no, playing forward. Like that. So this is going to flip. If this is false, then we're moving backwards. Okay, so now, if the time has passed, and playing forward, then we do these things. I think all of that is true. And then else if the time has passed,
Type that in global space.
sir?
You're in global space.
I think you're missing a bracket.
You went too far down.
Yeah, I'm missing a bracket. That's there. This is there.
You're missing one for the big if.
Yeah, this. Yeah, I need a closing bracket down there. Does that fix it? Yeah, okay. And not playing forward. In other words, playing backwards. And the time has passed. Then we do all these things. So I'm just going to copy this. Paste that. But this changes. Now we're going backwards. This goes backwards. This doesn't happen at all, right?
No. Well, it will say just play forwards.
This doesn't happen at all. This has to be adjusted. Current frame. What are we saying here? If it's playing forward, we go through this. Now if it's playing backwards, we're going to go back a frame. Actually, this should still be positive. We're going to count. We'll still count forward, but we need to move our rectangle backwards. And then at some point we have to flip this bool from playing forward between true and false. So here in our else, we'll write another else. playing forwards equals false. And then here, we do have an else, and we're going to flip this to playing forward equals true. I'm sure I'm doing something wrong and I'll have to debug this, but just thinking through it, that seems, I don't know, that's the first thing coming to my head. So we want to get that oscillating motion for the duck. All right, so let's try it out. Let's go to our duck. Let's include our animation. This is include animation.h up at the top. And then we'll add some animation pointers to our class. Where do I want to drop these in? Drop these in here. Animation. How many animations do we need?
For the duck alone, like each frame.
No. Animation is a set of frames. Looks like 4.
Yeah.
Well, these are not animations. I mean, we could call them like 1 frame animations, but it's 3 animations and then 2 still frames or single frame animations if we wanted to go that route.
Actually, 9 animations.
What?
And there's 9. There's 9.
For each installment, for like each color, you need 9 because you're saying 3 for 1, 3 for another.
Because it
Actually,
matches.
there's 11. Actually, sorry about that.
What are you talking about?
11.
When you look at the black and green bird, there's 11 sprites.
Okay, but that's an animation is a set of sprites.
Okay, so there'd be 4.
Yeah, it's like this. This is an animation. This is an animation. This is an animation. Right?
I guess I learned something today.
Okay, so it looks like the duck has 3, and then it has 2 still frames that we'll deal with. We'll decide if we want to make that a single frame animation or we just want to handle it as a sprite. But for right now, we want the duck flying. So 3 animations. We'll call this fly straight. Fly angled and
Fly down.
fly away. Fly down? And if you don't like those names, you can name it whatever you want as long as you keep up with it. Be consistent. So flying straight, that's going to be like the horizontal where he's just looking straight. The angled is at like a 45, and then the fly away is straight up. And like I said, we'll deal with the other ones later. We'll have a current animation pointer that'll point to whichever one of these guys we are working with at the time, and we'll just update whatever the current animation is and go from there. All right, where do we instantiate these animations?
And you create duck.
Will we do it in Create Duck? I think I'm going to do it in the constructor. Yeah, I want them already done by the time I create a duck, because I want to create ducks on the fly, and I want all of these animations loaded up before then. And we reuse these animations. So, yeah, let's just try the constructor. This constructor, duck constructor that takes the renderer. And then we have to fill out all of those parameters that we put in there. I wish the IntelliSense would help me out here. Do what?
I got like little arrows that popped up when I like type it in. You click on the window, it expands it. What it tells you.
So there's two overloads? I don't know. In NetBeans, I would push Control P and that would work. What the? I don't know. So I need texture.
We got a semicolon.
Oh, did I?
Yeah. Duck CPP. The semicolon after animation.
Oh, here?
Yeah.
No, I didn't forget that. I'm just not there yet. So we need the texture. That's our main texture. That's the duck's texture. Oh, we'll need a rectangle starting point. All right, so let's do that. Texture, rectangle, starting point. Duck CPP. Texture is going to be the duck's texture, so we just type text. The duck should already have that, right? Yeah, that's right here. And then the rectangle, let's plug a rectangle in here. And we need all of our starting information. The thing is, if I do this, this is only good for one duck. Maybe we should do like Theodore said and put.
Let's just take it slow and steady, like just throw one duck at a time.
Polymorphic duck.
So like create like a base class, like put all that information in one and then just using it all and overriding it for each duck.
The only thing that's really different are the animations. So what we can do is we can create the animations after we create the duck. Tell you what, we're just doing a black duck right now anyway, so we're gonna custom tailor this to the black duck, and then we will override it if we need to. These are things that are not really right or wrong in programming. It's just you have to make a decision, and you want to make the best decision you can, but you don't always know. You know, is this a good idea, a bad idea, etc. So there's our rectangle. Our starting X point is going to be the srect.x. Hey, IntelliSense woke up. Total frames, 3. Double frame time. So how long does each frame last?
Millisecond?
A millisecond?
Wait.
Boy, you better start shooting real quick.
No, I'm trying to think of how many seconds.
Your monitor only,
How many
it's
seconds
like
are-
60 hertz.
Yeah. Oh my god. So how many seconds are in a frame? Like
16.6 milliseconds in a frame.
Okay.
I just started blasting.
So that's one frame. That's one frame right there. If you wanted 4, you can multiply that by 4. So that would be like 4 frames per animation. Well, it may be too fast. We can come back and adjust it. Play backwards is true. We can leave that out. If you define that true, in case you don't know this, if you define or if you give it a value in the constructor, you can do this and that will be true and you don't have to put it in there. But any other arguments that we add to this constructor later on will also have to be set equal to some default value. That's the rule with default values and functions and constructors and things like that.
Can we go ahead and put true just to be on the safe side?
There's nothing unsafe about this. You can put it there for your own peace of mind if you want to, but you don't have to. The whole purpose of doing that is so you don't have to worry about these arguments unless you need to change them. We assume it's normally going to be true, so just don't worry about it. Alright, so there's our flying straight animation. The next one is going to be fly angled. And then this rectangle will be a different rectangle. The X will be the same, the Y will be different. So we're going to move down rect.height.
Can't you use the same rectangle and just change the values right there and pass them in?
Use the same rectangle.
Yeah, just alter the value before you pass it in. That's what
Yeah, as long as we go back and reset. We're going to go off the animation anyway. So yeah, I think you're right.
That's what I did with my buttons on the last line.
If we just draw, if we're only drawing based off the animation, then I think you're right. We can just change the Y. We don't need a new rectangle.
Yeah, that makes more sense.
Well, I was thinking, well, we have to reset this back at the beginning, but we don't. We're going to go off the animations instead. We're not drawing straight from this rectangle. And we'll leave all that the same, and then we'll add our last one in there. And we'll adjust the S-rect again. So that drops us down to the third right here. Or actually, we're on the black duck, right?
Yeah.
So we're right here now after we've dropped down twice. The rest of that will be the same.
You change it to fly away instead of fly angle.
Right. And then we'll set current animation to, let's fly straight. We'll start at fly straight. Now our duck draw will have to be updated. This S-rect is not going to come from the duck. Where does it come from?
Sprite sheet.
In other words, animation.
You have the N before the E in your variable.
Yeah.
Where you declared it.
You declared it as.
Yeah, we declared it as Kernet.
What?
We declared it as Kernet animation.
I wrote it again?
Yeah.
I think I auto filled that in. Kernet.
Kernet.
I wonder what this will look like.
Okay. So we got that fixed. That's working. This is. That's good. All right. Are we all caught up?
Yeah.
Do we understand how this works now? Why I changed that?
No, I don't understand.
What? The animation controls which part of the duck needs to be drawn. That's what's moving around on the sprite sheet. That's where we have our timer set up.
Okay, that makes sense.
So when I draw this duck, I'm going to draw based on the animations rectangle, not on whatever rectangle I plugged in for the duck. Like, technically the duck doesn't even need a rectangle now. It needs the destination rectangle. It doesn't need the source rectangle because the animation is in charge of that. So every update we have to update the duck's physics and update the animation. Let's just see if the animation works. There's no way it does, but
I checked.
current animation update, and it will need delta. And then duck will also need delta. Let's say this is a double, right? Double delta. Double delta. And we can pass our update. I put float there, but it would still work. Double delta. Okay, delta's going everywhere. Double delta. All right, I hopped around a little bit fast there, but
Yeah, can you repeat it?
anywhere that we're updating, let's just start in duck CPP or duck.h. Duck.h here. When we call update, we're going to pass it delta. So write double delta there. Then you head over to your source file. You can hold control and click on one of the working functions. It will take you right there. We're going to pass in delta. Animation's also gonna need delta, so we do the same thing there. In the animation.h, we have an update delta, double delta. And then in the CPP file also, passing in delta.
So I tried to debug it, and it says that the duck update function in the gamestate.cpp won't work.
You didn't put delta in the duck update in the game state.
Yeah.
Did we even make a duck yet?
Oh, okay, now it will work. Let me see.
We have a duck on the screen.
You gotta add delta to game state CTP too.
Okay, yeah, now.
Yeah,
There it is.
this duck is gonna need delta.
There's still no animation though.
No, there shouldn't be yet. We gotta get it all fixed. Is delta available here? Delta is here. Right, we calculate delta here. So there's that. Now let's see if it works. No. Doesn't work at all. Duck's broke.
Magic duck is magic duck.
Duck is broken. Duck OP, please nerf. Okay, so what's going on here? The update. The animation should update. So we know it got the texture because it did draw the duck there. Let me make sure that our delta is correct. So what I'm going to do here is I'm going to see out time passed. This is a common debugging thing. If you need to know some information, we just do some cout statements. Sometimes that's better than using a debugger if you need to debug in real time. I don't have IOStream up here. That should give me my cout statements. All right. Time passed is 0. So that's why nothing's happening. Now, why is it not updating? Do I have bad math back here at delta? We go to our game state. So I'm going to do that same thing here. Let's see out delta.
Put delta and update in the game state CDP. It's like all the way at the bottom with duck pointing to update.
Those are doubles. Get the time. So it's like 5.
It's in the game state CPP.
Equals 6 minus 5. 1 divided by 1,000. Okay, so these need to be switched. You calculate current. I think that's the problem. Now, the animation is still weird. It plays, but it goes one too far and then it stops.
Oh, yeah.
So we need to go back and look at that and see what's going on here. So if the time passed is greater than the total frame time, and we are playing forward, time passed equals 0, current frame moves. All of this happens. This works.
Okay. I got to the second frame because I got to go to the second frame. It didn't turn to a red dot, but it was still a black dot. But it's only stuck in the second frame.
I think this needs to be less than total frames. Do we start current frame at 1 or at 0?
Let's try 1.
Or did we start it at all? Current frame equals 1. Was that the last animation?
That's the second frame.
No, that's the third frame.
No, that's the second.
Oh, yeah.
Okay, so if we're going to start at 1, no, we'll start at 0.
Okay, it's weird because what I did earlier is in the game CCP, I put the current to plus equals SDO, get ticks, and it goes second frame. And then when
But don't do that.
I know, I got rid of it and I did what you did, put make thing equal to 1, and now it's on the third frame.
Just don't guess at stuff. What you're doing, even if it changes things, it's not right. It's okay to toy around with it some, but now is not the time for that. What you want here, this needs to be current frame less than total frames if we start at 0. Just like working with an array, and that should bring you from 0 through the third frame. Yeah, that's our third frame, so that's good. Now we need it to play backwards, and that is not working. So in this else, so if we have reached the total number of frames, or if we haven't, or wait a minute, where are we at? This should not be an else. This just needs to be a if current frame is less than total frames. 1 less than total frames. That's what we need here. So instead of else, this should be if current frame equals total frames minus 1. So that says if we are on the last frame.
Hey, I know, right? It's like words or something. It like flies.
Oh,
The picture.
it just keeps going left.
Later.
It just, I don't even know what happened. Yeah, it looks like it just.
Okay, from there, if it doesn't play backwards, we restart. If it does play backwards, playing forward equals false. And we should go into the case where the time has passed and we're playing forward, or we're not playing forward. So it should go here next time.
You need the double equals on the if step.
Ah, filthy SQL.
Oh, okay. It worked and then it stopped.
Yeah.
we just gotta get that to
Well, that just means this logic in here is wrong. So if the current frame is less than the total frames, do we set current frame to 0? Alright, that needs to happen as well. When we switch into this state, current frame equals 0. I told y'all this wasn't going to work. Y'all didn't believe me. Y'all were going to be like, yeah, first try.
The only thing that ever happens first try is
Alright, so what does that do? Gets us one more.
It goes straight back to the first one, stop.
And then we need playing forward equals true, current frame equals 0. Maybe this time. Come on, Duck. Hey! It looks kind of weird, but
Yay!
totally doing it.
Wait, what'd you do?
in the second house.
I didn't think we actually did something.
Resume. This minor adjustment right here. This if statement needs to match the one above. That's why we get that frame lag when the duck brings its wings down. But that gives you smooth animation. And
so what we have changed?
this right here, this needs to be an if statement instead of an else. And he's flapping pretty fast, so we can go adjust that if you think that's too fast. I'll give everybody a second to get this. This should be your animation CPP update.
That's better.
And then where we create the animations, that's where we adjust the frame time. So if you think he's flapping around too fast, you can go back there and make it ×5 or ×6, and that will give you more frames.
Wait, where do you go to ×5?
Yours is wrong. I don't know what you got going on there, but
Well,
it shouldn't be that fast.
while I was trying to fix that problem, I seem to have missed something.
Something is wrong.
Yes.
That's not supposed to look like that, Jared.
Wait, how's it look?
It looks like an empty
Just-
escalation.
What's the other?
Oh, it's just, you know.
Anybody remember how to do that?
Wait, overload or override?
It's an operator, overloaded operator, plus equals.
Boy operator plus equals.
What's coming in? Some vector. And then this x plus equals vec.x, and this y plus equals vec.y. That will add the vector on the right to the existing values of the current vector. In theory, if I did that right, I may have screwed that up, but that feels good.
That's all that matters.
What?
Could you go back to the previous slide that you're on?
Where were we? We're in the duck.
Yeah, the duck.
So position plus equals velocity.
Okay.
I don't know if that's right now that I think about it. And if we set our duck's velocity up in the constructor, we say velocity.x equals 100, and the velocity dot y equals -1, -10. I think this is going to be, I think that's going to be wrong. But anyways, our rectangle is going to be updated based on the position. Sorry, that's the destination rectangle, not the source. Sorry, I haven't done the physics in a long time, so this will maybe take a little trial and error. Oh, he's gone. He's super fast.
Put that.
He won the game,
Velocity times delta. I think that's right. So now I need to overload this operator. So let's go back to the vector. We're going to overload an operator to accept a multiple by a double. Double, let's call it num, I guess. I don't know what else to call it. That broke the game.
If you put position plus equals velocity in parentheses, would it do anything?
Yeah, probably. This is wrong. Sorry, that's wrong. Put this in. Our operators are not working, so all that was garbage. But this is the physics.
So can we get rid of the operators?
You can. Or you can leave them there. We're just not using them when we do it this way.
So let's keep going up and up and up. How we would like right now.
Oh, we'll get to that. We just got to get the mechanics in there first. These values up here I hard-coded just to get him to fly some direction, but when you change this, like if you make this a negative, he'll go left. And he flies off the screen immediately because there's no room. But that controls the direction of the duck. The X and the Y velocity, that controls the direction he moves.
I like how with the Y, it's negative, it goes up, but if it's positive, it goes down.
Yeah, that's computer graphics for you. It's backwards from the Cartesian system. It's like you're working in quadrant 4, sort of. All right, any questions on that? You got it? Okay, we got motion, we have animation. We need to add some rules. It needs to stay on the screen, right? So let's put all that in. What does this say right here?
If it goes past the border, it'll
If it goes past which border?
the left
Okay, yeah, if we're going off the left side of the screen, what do we want to happen here?
bounce back, go the opposite direction.
What is that? How do we write that?
You want it to flip in the other direction.
Okay, so flip equals SDL flip none. Because right is the normal. What else?
Wait, what if you flip horizontal?
Hmm?
Because
There's no flip. If he's going off the left side, we want him facing right, which is normal. So flip is none. What else? How do we keep him from moving left?
Well, if he's going 15 degrees this way, he's going 15 degrees back that way.
Okay, but just with the X. That doesn't change the X.
So what was the question, Ali?
How do we keep him on the screen? What does that mean?
you gotta make sure like
One thing, if he's going off the left side of the screen, which way is he going?
He's going left.
Okay, what does that mean? Velocity X is what?
Negative.
Negative. Yes.
yeah.
So let's change that. Equals what?
Negative.
Velocity x.
I think we need to give this duck a speed. We want our ducks to go different speeds, right?
Yeah.
All right, so instead of hard coding this 100 in here, let's give this duck a speed.
A random.
Duck. Where's a cheat? Just hold control and click on something. It'll take you back to duck.h. And here in the floats, we're going to put a speed. And we'll set this, the default will be 100. That's our normal duck speed.
Do you have a speed in the x and a speed in the y?
That's what the velocity vector is for. The speed, velocity has a direction. So that will have x and y. Speed is just a scalar. It's just a number.
Okay.
It's like a one.
So these will just be speed. I didn't really change anything because I have that.
Divided by 100.
Okay, so our velocity dot x will equal speed. And now we'll write the other side of this statement. Position.x is greater than what?
How we're fixing the screen is
How big is our screen?
720, or 1280.
1280.
Sorry.
Flip equals horizontal.
SDL flip. Horizontal. Velocity.x equals what?
Speed.
I will keep him going right off the screen.
Negative.
Negative speed.
That works.
Of course it works.
Okay.
Oh, we just gotta do something with the Y.
Position.y is less than 0. We're not concerned with the flip, right? Because he doesn't have downward animations. But he is gonna. We will want, if he's flying down, we do want him to take on the flying straight animation. It would look kind of funny if he was flying up and going down. Or facing up and going down, I should say. There's no flip there. We may want to change the animation though. Current animation,
Howie,
sir.
can you take the one flying up and just rotate it 180?
I'm not doing that. That's not how the game works.
Yeah, no, it's,
You could do that.
but we're not.
I don't want to get into that.
This is for game.
We'll make sure the current animation is what?
Flying, angle.
Not arrow. I don't want to put an arrow there. Current animation equals flying straight. And then what?
Velocity.y equals speed.
Okay. I like that. And then the last one. Now we got to account for the grass. Where is the grass? We don't know where the grass is. We'll just put some number in there. We'll come back and fix that. Right, Shannon? If he hits the grass, current animation equals fly angled.
Yeah.
So he should be flying straight if he's going down. Current animation equals flying angled, and velocity dot y equals what?
Negative speed.
Negative speed. Let's see what that does. It should keep him on the screen.
Yay!
Yeah, exactly. There, so
Oh wait. Oh no. Okay.
we might not.
Ooh, that's cool. Oh, that was.
Now he'll fly off the right side of the screen a little bit. Why is that?
Because it's,
It's top left corner.
yeah.
Yeah, we're looking at position being.
This is like a screensaver.
It is cool, bro.
We know how to program
We can fix the little issue with the duck getting off the screen by centering our rectangle over the position rather than having it based on the top left corner. So the position of our rectangle is going to be his position plus the half width of the rectangle. So I will scoot it over halfway. And then he should be centered up in all directions. He'll fly like halfway off the screen, but he'll never like disappear from the screen. If we wanted him to stay completely on the screen, well, that didn't work. Why is he going off the screen? Is it really a 1280?
Well, we can check.
That's what we said it
I was about to say, my projectors flew away and come back.
Yeah, this is wrong. Something is wrong here. Position dot x.
It's 1280 by 720.
Okay. Then my math is wrong. Minus. This should be minus. Sorry. Yeah, we gotta scoot back. We'll move our rectangle back a little bit, and that should keep it on there. Now, if we wanted better borders than this, we decide this is still not good. He still kind of gets off screen a little bit, which he will. Then you just need to trim up these numbers a little bit. Okay. Now, there's a case where this one, this only needs to happen if he's in his flying state. If he's in his fly away state, we're going to have to deal with this, because that's going to keep him on the screen instead of letting him fly away.
So can you put a bool in there?
Well, we have a state machine. So let's move this information into our state. So we'll take everything from keep the duck on the screen, do a Control X, and drop that into the alive. This is what happens if the duck is alive. In other words, flying around. He's dead, he does that. In the case he flies away, we can do this now. We can set our animation. Current animation equals fly away.
Where was that? Yeah, there's also called fly away.
Are they both called fly away?
Yeah.
Yeah.
Okay.
Oh yeah, that's bad.
Yeah.
We could call them all animation. Fly away animation, fly straight animation.
Fly away or something.
But if we wanted to see this, we would just set our duck. Where do we set the position of the duck? Is that back in the level game state? Yeah, in the level constructor, that's where we create the duck. We set his position down here. We can scoot him over a little bit and set him down towards the bottom. And we can set his state to fly away. Duck state equals fly away. Oh, it can't see fly away because that's part of the duck. All right, we can test that somewhere else though. We can scrap that right there, and we'll go back to the duck. And change that to fly away. And it should fly straight up off the screen. Oh, he'll just fly down.
That's not how that works, though.
Doing it wrong.
What are you, stranded? You didn't die correctly. Michael Jackson.
Is there a way we can put both vertical and horizontal flip on one thing?
Yeah.
Okay, because I was testing out with the flip vertical with the angled, and it's like it'll look weird but come down. So I was like, find a way, because like if it goes up and I flip it angled, it look weird. But I want to like flip it another way.
You can flip horizontal and vertical if you wanted to with a pipe. You can. I don't think you want to do this here, but you can do this. You can order your two flips. You can order the two flips together and, or maybe not. Why is it not letting me do that? I'll let you cast it. Yeah. No, it doesn't like that either. I don't know. There is a way to do it. I'll have to look it up. There's a note on it in the SDL docs. It can be done, but I know there is a special note on doing that. What were we doing? We said if he's flying away, he should be moving negative speed. Really, is what this should be. Negative speed will fly away, and he should. Yeah, there he goes off the screen. Why isn't he? I don't know why he's not starting where I moved him to. There he goes.
Wait, go back to that. I was concentrating on something else. Oh, here's
Sorry, these should be the same. These should not be different. Those should be the same. And the last thing I want to do for that is when he's flying away, it should be flying faster. So in the duck fly away state, down here we can say negative speed times 3, and then he'll fly away 3 times faster than normal. That kind of makes me want to adjust his animation for flyaway to be that really fast one too. Set it back down to 4. This is just personal preference. This is not overly important, but whatever you think looks good. Yeah, I like that. All right. Okay, so let's go to the duck and make a case timer or state timer. Make a float state timer equals 0. And back in game state, or no, back in duck. There we go. Back in duck here. In every case, we're going to update I say that. This is a disadvantage of using switch-based state machine instead of a polymorphic one, but the duck's not complicated enough to justify a polymorphic state machine for his AI. But state timer plus equals delta, so it will always go up. We'll just reset it to 0 when certain things happen.
case dead?
Well, we have to think about this. He's going to get shot, and we want him to play one animation or show one frame while he's being shot.
Yeah, like pause for a second.
Did you go back up where you put the state timer?
Like, there's a shot.
I'm not even sure this is right. I don't know if I want that.
We probably should make this a shot case.
I don't think I want that there. I'm going to take that out. Like, this is the beauty of polymorphic state machine, is we would set this timer to 0 when we enter the state, but enter only happens once. With a switch-based state machine, we enter case dead every loop. So then you kind of need a bool or something to control whether or not you start the timer. The state timer is greater than, how long should he like hang out there being shot? Half a second?
He's out there for like 2 seconds.
No, he's not.
Yeah.
Alright, someone
2 seconds is a long time.
Hang on, we'll shoot a duck.
How long does it take a duck to die?
We can play with it as needed. I'm going to start at half a second. So if the state timer is greater than half a second, he's going to fall. So I'll put this code up here. Else velocity is 0. So I wrote it backwards. It will hit this one first, and then it will do this one. And then in this case, the duck's current animation is going to be what?
Fly away. Wait, no, dead. Well, do we have an animation? Do we set an animation for dead?
And then this comes the question, do we create animations, single frame animations to control this, since our draw function is based on a current animation? I think that would be the easiest way to handle it, is just to say,
Oh, there is an animation for that. It like spins. It just keeps like there's that
It's a
like,
flip.
Animation. It just keeps flipping when it has it like all the way down.
it flips, but it's not an animation. So let's add an animation for a dead duck, or let's try this. This may work. It'll be a single frame animation. And then a CPP, we'll say dead equals new animation with our texture, our source rectangle, what's the 3 for?
How many frames? The photo frame.
Yeah, so there's just one.
Yeah, and then this last number, it doesn't matter. And then we need to move the rectangle to the being shot, or to the dead state, and then we need the one for the shot state. Where is that picture? Okay, so shot is going to be down 1. Dead is going to be over 1. So we should do shot first and then do the dead. Shot equals new animation texture srec.x 1 and then 0.5 for half second, and then we move our rectangle again. But this time we're moving right because the frame is 1 to the right. So we move the X. We'll leave the Y alone. Plus equals srec.w because we scoot over 1 frame width. That's for this one right here. And I don't know if this will work. I don't know if our animation class will handle 1 frame or not. It should. Oh, we can set this thing to false because we don't go loop. That will keep it from tripping back and forth between. Now we'll still have to deal with him flipping left and right when he's dead, but we'll deal with that in the dead state. Everybody got this? And current animation, let's see, what were we doing? This is shot. And up here it'll be dead.
So shouldn't we have like that whole mouse button down and up thing in case where you click it, activate the dead and then go straight into
So we'll have to shoot him, is what you're saying?
Yeah.
Can't believe you're so eager to shoot this duck. Spent all this time getting him alive.
You're making me mad.
Bringing him to life, and you just want to shoot him.
Getting him to be alive is a hard process.
Alright. Game state. So, case mouse button up. We're in level. In game state. In update. Mouse button up. We need to check collision of the mouse and the duck. So if SDL has intersection with the duck rectangle, and this has to come in by reference. And the mouse point is a rectangle, right? Yeah. So if those collide, the duck dies. So duck state timer equals 0. Why is it angry?
I think you're missing a parenthesis.
Yeah, I was looking at that. I was like, what?
And duck state equals dead. Won't let us do that because the enum is locked up in the duck state. So what we're going to do is write a function to kill the duck. So duck.h, I've added void kill duck. Here we can say state timer equals 0 and duck state equals dead. There's little duck state.
Why is that too little?
Oh, but it keeps going up.
Squeeze the trigger.
He's going to heaven.
That was like the most miserable dog.
He died because we love.
Hey, Allie, when my duck dies, it changes to a different duck color with you.
Why is this not there?
That means you did it wrong.
Yeah.
That's positive speed if he's going down. Bam!
Oh my gosh.
Well, he's too slow. That needs to be way faster. Speed times 3. Bam! Yeah, I like that. Kill him again. He's trying to get away. He's trying to get away. Bam! I love it. Feels good.
It doesn't do the other animation.
My animation doesn't work.
Oh, no.
It doesn't do the other animation. And it doesn't go
Doesn't
down.
make the dead animation, but it gets shot.
So that's the whole
Oh.
game. You just go from there, win screen. Right?
There we go. We're done.
Right.
Easy.
Never.
We can just set this to if duck state does not equal dead. And then I don't think you'll be able to shoot him. Yeah, you can't kill him again.
I don't know though. I might sit in pretty fun. We could get it to where it starts flipping when we kill it.
Yeah, you could spin it if you wanted to do that. Oh, you mean like while it's falling, it needs to
Yeah,
be.
while it falls, it like it spins.
We need to do that. That's good.
Oh yeah. So just flip it.
Oh, I hate this. I got too much stuff open.
I don't want to get.
Because I have my finger in front of my mouth.
Okay, in duck.h, I'm going to put a flip timer. And set that equal to 0. And then in the duck dead state, so case dead, this is where he's falling right here. It's not a bool. I don't think we can just say flip equals not flipped.
It's an int, so.
So what we'll have to do is we'll have to say if flip timer is greater than 0.1, if flip equals SDL underscore flip
And
horizontal.
double equals.
Yeah, it does. I hate database. Database did that to me. Else flip equals SDL flip none. In every case, we're going to set the flip timer back to 0. And then every time we're going to add delta to the flip timer. That should work.
That's it. Nope.
I can't even shoot it anymore.
No, that didn't work. What did I do wrong? It's in a loop. Oh, the problem is if he's already in the not flip state, this doesn't happen. So I think I'll have to say if it's flipped horizontal, the flip equals flip none, and then if it's flip none, we go flip horizontal. No, this should be none. To prevent this from going from here straight into here, we need to brake after this right here. Because otherwise, it will jump straight into here and flip him right back. Alright, that should, I think that will work.
All it does it once, like.
He's flipping really fast.
Well, it flips like once for me and then stops.
I don't know why this is not working. Boom.
Mine flips like extremely fast.
Yeah, so does mine. If the flip timer is greater than 0.1.
I'll just follow along.
0.2? No, it's still flipping too fast. The brake is going to take me where? Brake will get me out of... That should...
Out of the second ditch.
That gets me out of the case. So next time I enter the case... Oh, if we brake, the flip timer doesn't get reset to 0. This has to happen earlier. The flip timer has to be reset immediately. That should take care of it, and this will go back to 0.1.
Oh, it does it once.
No, that works perfect.
Well, I don't know what
Yeah, it
you
works
did.
on mine.
What'd you change? 'Cause
We'll do a point. I'll try 0.2. That's too slow. 0.2 is too slow. So like,
It only flips one time for me else.
okay, you need to look at this logic then very carefully. Make sure this matches exactly.
Oh, okay, I see what I'm missing.
I need to start the duck higher for shooting it.
Yeah, it works.
I don't know what is wrong, but let me try it. See if they shoot.
Why is it so cold in here?
That's it. It's cold. Boom! Love it. It's a good game. I think it's mostly the art, but I like that. All right, let's call that good for today.